Okay, this is the recorded lecture for week 4, the methodology issues and statistics. I'm just going to briefly go over a few things from the text. There's not going to be a whole lot to this. It's going to be fairly short, and then we'll talk about some of this stuff in class because I do think that this may be some things that are a little bit more difficult, and so we may want to talk about those in class. So be sure that when you come to class that you have brought any questions that you have from the chapters that are assigned this week. So first of all, let's look at methodology. Okay, all the methodology is other than a word that's sometimes hard to say, is the process that we use to collect and analyze information and data for the purpose of answering our research questions. It can include the type of study you're doing, who your participants are, what kind of data you're going to collect, the way you're going to analyze that would you describe your statistical methods that you'll use to analyze and interpret the data. So that all it's the method that you're going to go about to try and make meaning of the information and come up with an answer to a question. The most important thing to remember is that your study is only as good as your methodology. If your methodology is faulty in any manner, then your conclusions are not going to be valid. That's why it's important, if you're not great at this, that you have somebody on your research team that really is good at this and understands all this and helps you to set this stuff up. So the stuff in the variables from the book that I want you to be sure that you understand, this is an important thing to review and bring any questions you might have to class. A variable is simply something in your study that can change or will vary. And the two most important ones to understand are the difference between a numerical variable and a category. So a numerical variable is going to be something that has a number attached to it. It can be an IQ score, a GPA, a temperature, your height, anything that absolutely has a number assigned to it, okay? And you're making meaning of that number. Categories are just exactly male, female, race, ethnicity, religious affiliations, Republican, Democrat. Those would be categories that don't necessarily have a number assigned to them. Okay, dependent and independent variables. Those are the things that you are studying. Okay, the dependent variable is what depends upon the independent variable. Will it change based upon what you're doing? So the independent variable is what you are studying. Or it's what you're manipulating. It's what you're manipulating. And dependent variable is what you're looking to see if it changes. So let's say that in a school setting, I'm looking at reading comprehension scores. That's my dependent variable. The independent variable might be a particular instructional strategy that I use. Looking at students' reading comprehension scores based upon whether a whole language approach was used or a phonetics approach was used to teaching. So what changes, the independent, is what you're manipulating. If you're looking at this from a counseling standpoint, let's say that I want to know about the decrease in depressive scores. So depressive symptom scores is the dependent variable. And I want to know how those change based upon whether I use a person-centered approach or a CBT approach. So what's different is the independent variable, and that's going to be person-centered or CBT. The dependent, what I'm looking at, what it depends upon, the manipulation is going to be their depressive symptom scores. So those are things that are important to remember. And the easiest way to remember that is the dependent score is dependent upon the independent score. Okay, population versus sample size. When you're talking about a population, you're talking about all the people who meet the defined criteria in the study. So let's say the population is SFA students. Okay, I want to research SFA students. I want to know why they chose to come to SFA. Well, it's possible that's 12,600 students approximately right now. It's possible that I could survey every one of the 12,000 students, or I may just want to take a sample of those. So instead of maybe 12,000, that's a big survey. So maybe I just want to sample, I want to survey 1,000 students or 500 students to see why they came to SFA. Okay, and I'm going to show you this in just a minute. The way there are technology supports that help you determine what kind of sample size that you need. So I'm going to show you that in a minute. And they're free online calculators that do that. So the difference between a confidence level and a confidence interval. A confidence level is how confident can I be that what I'm doing is right, or the results that I got are right. So a lot of times you'll do a 95% confidence level. I'm 95% confident that this is accurate information. You see this a lot when you're doing any type of achievement or aptitude testing. So say I'm going to do an IQ test, and I'm doing a 95% confidence level. That means I'm 95% sure that this is an accurate IQ score. But then I can also do a confidence interval. So let's say I want my confidence interval to be 5, 95% confidence level, a 5% interval. So my IQ score, I give somebody an IQ test, and it comes out that their IQ is a 95. If my confidence interval is 5, then I'm saying that score, I can be pretty confident that if I were to test that person again, then their score is going to fall somewhere between 90 and 100 because it's a 5-point confidence interval. I'm 95% sure that person's score is somewhere between 90 and 100 if my confidence level or interval is 5 and I got a score of 95. So be sure you review that stuff in the book and make sure that you understand the difference between those two. Okay, so I'm going to pop over here real quickly and I'm going to show you this determining your sample size. Okay, so I want a 95% confidence level. Let's say I want a 5% confidence interval. And my sample size, we're going to go with this SFA students. So we've got 12,616 students in the fall. I happen to know that. I just did a report with that. So I'm going to calculate, and that tells me if I want to be 95% confident level that the score that I get is somewhere within 5 points, then I need to sample 373 students. So that's how I determine my sample size. Now I want to show you something that happens here. Okay, let's say my population is 100. Well, this is saying my sample size needs to be 80 then. But watch what happens when my sample size is 1,000. Look at the difference in that. It's not 80% anymore. I only need 278 people. If it is, which is 27.8%. If I'm going to go to 10,000, the population is 10,000, then I just need to my sample size needs to be 370. So you can see that the bigger your population is, the smaller your sample size is. Now, this confidence interval. So let's say that my sample size is 370 and I have a population of 10,000 and my return rate is 50%, then I can say my confidence interval is 5. Percentage is how many people actually respond. So you can see that there are calculators to help you with that. Again, you don't need to be experts in this. You just need to have an understanding of what this means, and you need to know what resources are available to you. Okay, so now let's talk about underrepresented groups. Okay, so there's a problem if there are not enough individuals from underrepresented groups in your sample. So the question is, do you have enough adequate data to generalize for that population? So let's go back to my SFA population, okay, 12,616 students. Of that, we have about 15% of our students are African American. So let's say that I just do this random sampling. I've done I think, what was it? Is that I needed 370 students. So I have surveyed the 370 students. But when I look at that, and I look at from this sampling, that maybe my sample doesn't fall within those demographics. Maybe I don't have 15% of my respondents were African American. So I may be able to say overall, this is what, these are the generalizations for SFA students, but I can't do any group comparisons within my sample if one of my populations is underrepresented. Maybe only have 3% that were African American that responded. So in that case, you can do what's called purposeful sampling, and that is maybe you reach out and you try to you overrepresent that population in your sample to get an appropriate response from them. That could be the same for, I know that we talked about on one of the research projects, looking at holiday symbols. And so if you know that the majority of the people, vast majority of the people that you're serving are Christian, or that you're surveying are Christian, and you want to know some differences about other religious groups, then you may have to go out and be purposeful in finding representatives from the Jewish population or the Muslim population that would help you to make sure that you can generalize about that population. All right, statistics. This is where people get really nervous sometimes, so I don't want you to freak out about this, because we're not going to be doing statistics, and all you need to do is understand some very basic things. So when you are doing statistics, there are 4 types of scales for measuring what your variable is. The first is a nominal scale, and a nominal scale is when you use identifying numbers for categories that those numbers really are not numbers; they're representing something. So and you assign a nominal number so that you can put them in your statistical software and it means something. So let's say on gender that females are a 1 and males are a 2. Okay, those numbers don't represent anything but a category. If it was red, white, and blue, red is a 1, white is a 2, blue is a 3. Those numbers don't represent anything but a category. It may be, so let's say if we were doing something with SFA students, that we would use a nominal scale for their college. So 1 represents the College of Education, 2 represents liberal and applied arts, 3 represents business, 4 represents science and mathematics, like that. So that when you sort that data, that you can sort it by that nominal number, that the number itself doesn't have any meaning. So an ordinal rank is order, or ordinal scale is order or rank. So that can be class rank, it can be GPA, it can tell, people in the race first, second, third, anything that helps you compare people in some way, or compare a variable in some way, um, and that it puts things in order. An interval scale is a scale of some kind that has even intervals between the numbers, but there is no zero. There's no true zero. So an IQ score would be an example of that. IQ scores go based upon a 1 point scale. So you can have a 91, a 92, a 93, but you can't have an IQ score of 0. A ratio score is an interval score that does include a 0. So I think the example in the book is an age. So you can have somebody who is 0 years old if they haven't reached their first birthday yet. So that's really the only difference between interval and ratio, is that the ratio does have a 0 on it. Okay, the difference between reliability and validity. I guarantee you will have this question on your comps or your licensure exam. This is a very, very common question. Reliability, and you'll get this more when you talk about in your assessment class. Reliability just means, are you likely to get the same results the next time? Okay, so if and the instrument that you are using, if instruments have reliability and validity scores, okay, that if I give you an IQ test today and a month from now I give you another IQ test, that I'm likely to get a similar result. If I survey SFA students today and get some results, and I survey them a month from now, given that nothing significant has changed within the population, would I likely get the same results again? Okay. Validity is, does it measure what it says it measures? Okay. So, is it, if I'm going to use an aptitude test, it's going to give me your aptitude or your IQ, but it's not going to tell me about your academic achievement. I would need to, so I can't make any, if I find out what your IQ is, I can say what your potential achievement is, but I can't use that to say what your achievement will be, because it's not measuring achievement levels. Okay, descriptive statistics. This is when we actually start getting into the numbers part of it. So they describe data in a meaningful way. So it takes a lot of data and helps you start to have an understanding of it. So the most common are going to be a mean, a median, and a mode. Okay, mean is the average, median is the middle score, and mode is the score that appears the most in that. So let's say that I gave the research class a midterm exam, which I don't do. But I'm going to take your scores and I'm going to figure the average score or the mean score for the class. And then if I put that on, if it's a 0 to 100, then I'm going to see what the range of your scores are. Let's say that the range of scores were from 70 to 95. So what's the median? What's the middle score in there? And then the mode, let's say that out of 16 of you, 7 made an 84 on that test. Okay, that would likely be the mode. Okay, there's a difference, and I didn't put this on here. In fact, while you're watching, I'm just going to do it right now. There's a difference between a percentage and a percentile. Okay, a percentage is a certain amount of a whole. So if the test score had a possible score of 100 and you made a 70% on it, that means you got 70% of the answers correct. A percentile is how you compared to others. It is so if I have somebody, if 100 people took that test and you scored in the 70th percentile, then that means you scored better than 70 people who took that test. Does not mean you got 70% correct. And we'll go over this in class. Frequency just tells you how many of each number you got. How many people scored a 70? How many people scored a 71, a 72? That way. The range is the lowest score you got to the highest score you got. Okay, and then distribution of scores are how the scores fall according to the statistics. And you can have different types of distributions. A normal distribution is based upon a normal curve, but not all scores fall within, but all other distributions are compared to the normal distribution. And this is something we are going to go over in class, and that you'll see this. And then the standard deviation just tells you how far you deviate from the norm. And that is a statistic that is calculated based upon your mean. That you can't figure a standard deviation without figuring a mean. So the standard deviation tells you how far the scores deviate from the mean score. My husband thought that he was being real cute and real smart and showing his knowledge one day, and he told me, he said, I think you're one standard deviation away from the norm. And I responded to him. He thought that that was going to be like an insult. And I said, actually, baby, I'm 2 standard deviations away from the norm, but it's above the norm, and that's a good thing. So and that all has to do with the normal distribution. So we'll explain that in class. I'll bring in a normal scale and we'll look at that, and then I'll show you some of the different scores that you can derive from that and how they all relate back to the mean score. So be sure you've read your text before you come to class. If you have questions about the text, bring those in and we will go over them in class. Okay, see you next week.